This lecture begins our coverage on exchange rate theory. Our focus here will be introducing the concepts of purchasing power parity and the real exchange rate. From our last couple lectures, we observed that the exchange rate is that important price that allows for trade in goods and services across countries. We therefore need a precise theory for understanding how the exchange rate is determined, which will then allow us to make predictions about appreciation or depreciation of a given exchange rate and the implications of this for country level and global macroeconomic objectives. We do have such a theory though. From the last lecture, this comes from the uncovered interest parity condition. Rearranged, the UIP provides an expression for the exchange rate as a function of the future or expected exchange rate and interest rates across the two countries. Our task over the next two lectures is to find a model by which first the future exchange rate can be determined. In general, when thinking about any tradable good, that is, a good that can be traded across countries, we can assume that, absent any transaction or transportation costs, there should be no reason for the good to sell at different prices in the two countries. If this happened, you can guess what should follow. There will be arbitrage opportunities. But we've demonstrated previously that this should cause prices to eventually converge to the same amount. This equilibrium outcome is summarized in the law of one price, or the loop. The loop proposes that a tradable good consumed in any number of countries and priced at some amount in their domestic currency should all have the same price when expressed in the same currency. For example, suppose it's possible to purchase a pair of shoes for $200 in the United States, and the same pair of shoes costs 205 Canadian dollars in Canada. The loop says the US dollar Canadian dollar exchange rate must be 0.9756. That is, it takes 0.9756 US dollars to purchase a Canadian dollar, such that when $200 is converted to Canadian dollars, one ends up with 205 Canadian dollars. If the US dollar Canadian dollar exchange rate in the foreign exchange market is equal to 1, then the law of one price fails, and there is opportunity for arbitrage. Shoes are cheaper in the United States, and there will be increased demand from Canadians to purchase the shoes from the United States, as it costs them the equivalent of 200 Canadian dollars to buy a pair. The result is that there will be an increase in demand for US dollars, since shoes in the US are priced in US dollars. This will cause the US dollar to appreciate against the Canadian dollar, and so the US dollar Canadian dollar exchange rate falls until no arbitrage condition is restored at 0.9756, and the loop holds. We can generalize the law of one price as holding for all possible tradable goods, in which case we have the concept of purchasing power parity, or PPP, holding. PPP suggests that any basket of possible tradable goods representing consumption in each country and having an average price given by the price level, once expressed in the same currency, should all be the same. In other words, purchasing power as summarized by the price level in each country should all be the same when expressed in the same currency. So consider two countries, the United States and Japan. If their price levels are given by PUS and PJAP, if PPP holds, then the dollar exchange rate multiplied by PJAP should equal PUS. This expression can be rearranged so that we can state the dollar-yen exchange rate as equal to the ratio of the price level in the US, PUS, to the price level in Japan, PJAP. We continue to assume, of course, that there are no trade frictions, that perfect competition holds, and that prices are fully flexible in both countries. Note that the expression suggests that whenever PPP holds, the basket of goods in the two countries have the same value. That is, the US basket can be exchanged for the Japanese basket 1 for 1. This means the real exchange rate is equal to 1. Now we have introduced a new concept, the real exchange rate, which I will interchangeably use the acronym RXR or the symbol Q to represent. The real exchange rate measures the relative price or value of a basket of goods across two countries. So again, considering the United States and Japan, the real US-Japanese exchange rate gives a measure of the value of the Japanese basket as comparable to the value of the US basket, both being expressed in the same currency. If the ratio is equal to 1, then they have the same value and PPP holds. If the ratio is greater than 1, then the Japanese basket is more valuable as it takes more than one US basket to purchase a Japanese basket. PPP fails to hold here. Similarly, if the ratio is less than 1, then the US basket is more valuable than the Japanese basket, as it takes less than the US basket to purchase a full Japanese basket. PPP also fails to hold here. Again, make sure you are not confused by the earlier concept of exchange rates and this new concept of a real exchange rate. The earlier concept of exchange rates I will now refer to more precisely as the nominal exchange rate. It gives the price of one currency in terms of another. For example, the dollar-yen exchange rate is the nominal exchange rate. If this is equal to 0.01, then it takes 0.01 US dollars, which is 1 cent, to purchase 1 Japanese yen. The real exchange rate, on the other hand, gives a comparison of one country's consumption basket in terms of another. For example, the US-Japanese real exchange rate, if it's equal to 2, it means the Japanese basket is more valuable than the US basket, as it takes 2 US baskets to purchase 1 Japanese basket. Similar to the concepts of exchange rate appreciation and depreciation, the real exchange rate also experiences a real depreciation if the foreign basket becomes more valuable. That is, the US real exchange rate rises. If, however, the US real exchange rate falls, then the US basket has become more valuable and a real appreciation has occurred. Given the expression for the US-Japanese real exchange rate as the product of the nominal dollar-yen exchange rate and the price level divided by the US price level, the determinants of the real exchange rate can be seen in general. The nominal exchange rate and the two countries' price levels determine the real exchange rate. As a result, we should expect a real depreciation where a directly expressed nominal exchange rate rises or depreciates, or the foreign price level rises, or the home price level falls. Similarly, we should expect a real appreciation if the directly expressed nominal exchange rate falls, or the foreign price level falls, or the home price level rises. Thinking intuitively about why an identical basket of goods should have the same value across countries, that is, that the real exchange rate should be equal to 1, it is straightforward to see how the real exchange rate can be used to value relative strengths of a currency. If the real exchange rate for any two countries' baskets is greater than 1, then it is the case that the nominal exchange rate is providing a valuation that makes the foreign basket more valuable. The foreign currency is therefore overvalued. So if the US Euro real exchange rate is 1.35, this means that the euro is overvalued by 35% and is therefore strong relative to the dollar. Similarly, if the US Euro real exchange rate is 0.95, then the euro is undervalued by 5% and is weak relative to the dollar. When the real exchange rate is equal to 1, both currencies are at par and PPP holds. It should however be noted that this definition of PPP should be qualified and more accurately called absolute PPP. Absolute PPP is limited by the assumption that we are measuring baskets that have to be identical across countries. This is faulty in practice, especially when comparing developed Western economies with developing economies, whose baskets of consumption are obviously different. A similar concept to absolute PPP that's derived from absolute PPP is the relative PPP. This is found by taking the rate of change in the absolute PPP expression over two time periods. The result is an expression that does not have to assume that the baskets are identical across countries. Whatever is in the baskets is of no importance. What matters is how the value of the basket changes across time. So relative PPP says the change in the nominal exchange rate is equal to the difference in the inflation rates between the two countries. In our example with the nominal dollar-yen exchange rate, relative PPP relates the percent change in the dollar-yen exchange rate as equal to the difference between the US inflation rate and the Japanese inflation rate. Note that we arrive at these inflation rates from taking the rate of change in the price levels, which by definition is what the inflation rate is. And because you are dividing the price levels in the initial formula, this turns out to be a subtraction when taking the rates of change. Note also that the percent change in the exchange rate is also the rate of depreciation in the nominal exchange rate. The important question that we have to ask at this time is, how well do these PPP concepts pan out in practice? Well, empirical tests of both absolute and relative PPP show that they fail to hold over short periods of time. That is, a real exchange rate not equal to 1 is observed, and after a year has gone by, about 85% of deviation from PPP still remains. After 2 years, 72.25% still remains. And only after 4 years do we have about 50% of the deviation remaining. In other words, the theoretical PPP construct only works in the long run where convergence is finally observed. While this looks like bad news, in thinking that PPP had provided us with an expression for the nominal exchange rate that now doesn't seem to hold, the upshot is that it does provide us with such an expression, but now for a long run of future exchange rate. In other words, because PPP only holds in the long run, the various absolute and relative PPP expressions are good predictors of future, not current exchange rates. We will return to this idea in the next lecture. But first, what are plausible explanations for the failure of PPP holding in the short run? These are largely practical limitations, such as the fact that some goods are non-tradable, that there are transaction costs that are often not trivial, that market perfections exist which could generate market power through product branding, so that identical goods are not so identical in practice. There is also the possibility that prices are not fully flexible, but rather are sticky in the short run. Note that price level changes is the other route by which convergence to PPP should happen, if the exchange rate, for instance, operates under a peg. So if prices are not flexible, then convergence does not happen right away. It's therefore assumed that with time, either these problems go away or become negligible due to continued pressure from market forces, such that PPP ultimately holds in the long run. For the remainder of this lecture, we shall explore how we can use the concepts discussed so far in making short to medium term forecasts in the foreign exchange market. Suppose we are interested in forecasting a future value for the dollar-yen exchange rate. Then from relative PPP, we have an expression that says we can find what the percent change in the exchange rate would be if we know the forecasted inflation rates for the two countries. We can then compute the future rate given that percent change. This, of course, has to assume that PPP holds. As an illustration, let's suppose the inflation rate in the United Kingdom is 1.5% and in India it is 4%. If this is the forecast inflation expected to hold over the next year, we can compute the future pound-rupee exchange rate in a year's time if the current pound-rupee exchange rate is 0.01. Assuming PPP holds, we use the relative PPP formula to find that the percent change in the pound-rupee exchange rate is given by the difference between the British and Indian inflation rates. That is negative 2.5%. The pound is therefore expected to depreciate by negative 2.5%. That is, it is expected to appreciate by 2.5% against the rupee over a year. This means the forecasted exchange rate a year from now is computed to be 0.00975. Intuitively, the higher expected inflation in India compared to the United Kingdom would mean that the rupee is expected to weaken against the pound as the rupee's purchasing power diminishes from the inflation. What if relative PPP fails to hold? Since, as we have seen, most empirical tests show that within a year, the deviation from PPP is still substantial. We can still forecast future exchange rates, but now we have to bring in the real exchange rate to help out here. We simply rearrange the formula for the real exchange rate so that we have an expression for the nominal exchange rate in terms of the real exchange rate and the price levels of the two countries. Taking the percent change in this expression gives the expected depreciation of the nominal exchange rate being equal to the expected real depreciation plus the inflation differential between the two countries. This formula now allows us to utilize information from empirical studies to make an adjustment that takes into account deviations from PPP. First, we compute the current real exchange rate. Then we apply the 15% rule of thumb for convergence to PPP, and this gives us the rate of real depreciation. We add to this the inflation differential between the two countries, and this gives us the expected depreciation in the nominal rate. We can then compute from that what the future spot rate would be. Let's illustrate this with a slight modification of our previous illustration. Inflation rates in the UK and India are 1.5% and 4% respectively. The current pound-rupee exchange rate is 0.01. We want to find out the future pound-rupee exchange rate in a year's time if PPP does not hold, but if we know that today a basket of consumption goods is valued at 10,000 rupees in India, whereas an identical basket is valued in the UK at 105 British pounds. We first note that At the current exchange rate, this means that the real exchange rate is 0.952, making the rupee undervalued by about 4.8%. From empirical analysis, we know that in a year, only 15% of this deviation will be removed. That is 0.72%. This means the real exchange rate will have risen to only 0.959, which is a real depreciation of 0.756%. We can now add to this the inflation differential between the UK and India, which is negative 2.5%, and we get negative 1.7%. So the pound is expected to appreciate by 1.7% against the rupee. And so in a year, the pound rupee exchange rate is forecast to be 0.00983. We have now introduced the PPP and real exchange rate concepts and seen how we can forecast exchange rates when PPP is assumed to hold and when it does not hold by including expected changes in the real exchange rate. As PPP is expected to hold in the long run, the expression for absolute PPP will become our baseline model for a theory of future exchange rates. This we will explore in greater detail in our next lecture. Next steps therefore include taking the quiz associated with this lecture, reading through the chapter on exchange rates in the long run if you have not done so already, and getting started on the next lecture.